So hi everyone, my name is Guntis, I work at TestDev Lab, and today I want to show you this cool thing that we recently made. So first of all, I want to tell you a story about Tapster. It was made by Jason Huggins, the same person that made Selenium, Appium, and this robot as well. And he said that life is too short for manual testing, have a robot do it for you. That's why he built this, keeping in mind that it should be inexpensive, it must be easy to build at home, and it must be customizable for specific needs. So he designed this robot called Tapster. You may ask, what's the real purpose of this robot? So for us, we primarily have used it for battery usage testing, because for battery usage you shouldn't install more software on the phone other than the application that you're testing, because it might give false results. So it's like really simulating humans' fingers without any software interaction to the phone. It can be also used for automation, automating the parts of phone that can be done by software. For example, changing system settings or rebooting the phone. And yeah, and also for some fun projects, for example, automating some games that we also tried, as you may have seen at our stand. And next, where you can get one? There are two options. First, you can order already made one. It will cost you $750 plus shipping probably. Or you can do it by yourself, approximately 10 times cheaper. And I want to tell you more about how you can do it yourself. So here you can see all the parts that are required. Mainly these are plastics printed by 3D printer. It's really easy to do because all the models are open source available. The most expensive parts are servo motors and some more electronics. For example, Arduino Nano controller that controls the motors, and some screws that you can easily get at the local store. Also, this construction uses magnets because it's better, because you can detach it without breaking any of the connections permanently, which also costs some more money. The first thing you will need to do is assemble all the things. The good thing that there are already available online instruction how to do it. And you will also need some soldering skills to make the connection board. Or you can order like servo shield that has connections for all the motors, so you won't even need to solder anything. This is just more convenient for us to make it less expensive and more portable. Now comes the fun part, aka software. So here are some links for the software part. The first link is to original project, where you can download all the 3D models that you will need to print out. There are two versions, actually three versions available. The smaller one, the middle one, which is this one, and also the tablet version, which is like 2 times bigger, but we haven't made it yet because it needs a bigger 3D printer. The second link is our edition of the source code that we adjusted. We made a few fixes, calibration improvements, and the third link you can read at our blog how we made this robot, like step by step, all the technical stuff and more. So first steps to start the software. You need to upload the Fermata library to Arduino using Arduino IDE, which is also open source, of course. And you will need Node.js software installed on your computer. because the software is written in Node.js. And you just clone the project, enter into the directory, install dependencies, and start the server. The one thing that was most painful, so to say, was calibrating the robot, because the software that comes with it requires specific application to install on phone in order to do device calibration. So that's why we built specific browser site that can do the calibration. But first you need to do the robot itself calibration by specifying the angles at the config file, which is also, I suppose, written in the online tutorials. And we also made the boundary limiter to prevent it from going out of boundaries, so prevent it breaking. It can handle where are the edges. The calibration is needed in order to work with screen coordinates, because if calibration has not been done, you can only work at the card's coordinate system. But when you do calibration, you can know where the end of the phone's screen is. So you can also use it with automation frameworks by tapping exact coordinates of the screen. This is how looks the calibration page. Basically, it's written in JavaScript. It connects with the socket.io library with the backend, and when the robot taps on the screen, it just sends the coordinates back to the server, so it can map its coordinate system with the phone coordinate system. And also, this page sends all the information about phone, like web browser, screen resolution, and yeah. So it can be stored to save profiles of different phones. But this process takes around 10 seconds or something, so it's not difficult to calibrate the phone more times. Because when you move the phone on the plane, you need to calibrate it again, because the coordinates aren't like the same when they were when you calibrated. This solution is good because it supports Android, iOS, and probably Windows Phone as well, only if it has a web browser that supports the JavaScript and socket.io libraries. So yeah. It also can be used with Appium automation framework. We did a test. All you need to do is rewrite the tap method so it executes a REST API request to the backend, and the robot just taps where the coordinates that are sent to the robot. Yeah. So we have come to the conclusion. Should you build one robot? I would say definitely, because while we were building this robot, we learned a lot of new things. For example, how to print, how to 3D print, how to wire electronics, how to write software and do the calibration, which includes a lot of mathematical libraries. And it's after all, it's not that expensive. Is it worth it? Of course it is, because you can use it for whatever purpose you need. And is it practical? It depends. So for example, if you need to do some tests that are can be done more quality by using software, then just use software. But if you need some special test cases that you cannot do with software, then this solution might be the right one, because it can do more than just the software. Yeah, and now I can show you some demo of the robot, how it works. Basically, there's a control panel that can just I can show both at the same time, but basically you can do just the linear movements of the robot, and there is a record and play tool that you can just swipe your cursor over the screen, The screen is not refreshing right now because it's not connected to phone, but it can you can at real time see what exactly is happening at the phone. So you just tap on the image, it writes down the coordinates, and you can just play back all the written coordinates, and the robot executes them. Yeah. Basically, that's it. And